Okay, so finding limits. This is the biggest section on your test. So we talked about 4 methods. So you could plug in if it works. You could eliminate the problem, and that's usually a factor cancel. You could plug in close values, or you could just analyze with infinite stuff. Okay, so when I look at this is one I can just plug into. So the limit of this as we get closer to 6, I can just plug that in. So 6 squared, got that number, plus 3 is 39. Okay, number 2. If I look at this would be one I would probably try to factor. So the limit as x approaches 6, on the top I can see a difference of squares. Okay, you could see that I can't plug 6 in, right? Because it makes a 0 on the bottom, and 0 on the bottom is not good. Alright, so when I cancel, now I am able to plug the 6 in. So as this x gets closer to 6, my equation will reach 12. Okay, the next one, I can't just plug 6 in, the bottom 0, there's nothing that will cancel. So I'm going to plug values in, so I would probably do a couple on the positive side of it, and then I would do a couple on the left side of it. So from the right side, from the left side. Okay. If you want, you can work to get them. I'll do a cheat method here. Okay, so let's cheat. So I have x, I have the equation. So for me, on my calculator, this is what I can do. I'm going to store 6.1 as my x. So I get 61. When I put 6.1 in, I get 61. Okay, so now I'm going to have a 6.01. And I get 601. So 6.01, I get 601. Okay, so now if I go with 5.9, I get negative 59. At 5.99, I get negative 599. Okay, so what do you think? As we get closer to 6 from the right-hand side, what's going on? Looks like we're going to infinity, right? As we're approaching 6 from the other side, the left side, what are we heading towards? Negative infinity. So what's our limit? There is no limit. We're not getting towards the same thing. From both directions, we're not going to a conclusive answer. Okay, so the last limit thing you're going to have to do is just analyzing. So let's talk about my main ideas, that one paper I gave you. Okay, as the bottom gets bigger and bigger on a fraction, your number gets smaller, smaller. If the bottom gets bigger, bigger, you get smaller, smaller, which means you approach 0. Here, the bottom is getting bigger, 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 so you're going to get smaller, smaller, smaller. Okay? yeah, these are different with a positive and negative. This means you're approaching 0 from above. And this means you're approaching 0 from below. That's the only difference. But you're still going to 0, right? Doesn't matter. Okay, here, if my bottom is going to 0, so if my bottom gets smaller, 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 I get bigger, bigger, bigger. Here, if my bottom gets bigger, bigger, or sorry, my bottom gets smaller, 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 so if my bottom goes to 0, I go bigger. If my bottom's getting smaller, I go bigger. Okay, what do we know here? If the top is getting faster, bigger, 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 what do we think? Then this would be infinite or negative infinite. You would have to figure it out. Okay, with according to what numbers you would have. If you have a negative coefficient or something. Okay, this time your bottom is getting bigger. So if your bottom gets bigger faster, then we get to 0. And what if they're at the same pace? If they're moving at the same pace, getting bigger at the same pace, then you're going to have to figure out what number they're getting close to. Okay. So here's some examples of analyzing. So here's my thought process. So you're going to get 2 points for every question. 1 point is for you showing me your strategy. 1 point is for your answer. Okay, so what is going on here? What happens when it's 1 over 0? So what does this become? A negative infinity. Okay, now I'm going to change that. So 7 to the negative infinity. Are you okay if I change it to 1 over 7 to the infinite? Right? Because the negative exponent, I'm just moving it to the bottom. And same idea there. What's happening with this value? 1 over 7 to the infinite. What's that going to be? It's just going to make 0 eventually, right? That's such a small number, it's going to 0 out. Can we say the same thing about that? That's going to 0. It's basically going to get to 0. It's going to be so small. So what's my final answer? Think about 4 plus 0 on the top and 5 plus 0 on the bottom. So I'm eventually going to approach 4/5. Okay, next example. So this is going to be the same pace. So we're going to have to do some kind of division and figure out so I'm going to have to think about this. What's happening here? Okay, so I write now, I know it's like a 4 with a 1. but I'm just going to analyze what's going on. Is it going to end up being positive or negative? So what happens with that? Negative squared. So that's going to be positive. And then this is going to be positive, right? But I'm going to have to times that positive by a negative 4. So the whole top will be a negative value, and the bottom will be a positive value. So my final answer will be negative 4. These numbers are the same, so let's say you make them the same, like 1 million. So this would be 4 million on the top divided by 1 million on the bottom. That's the idea, right? Okay, so that's the one chunk of your test. There'll be one question where you have to analyze the visuals. Okay, so I don't know, I just zoomed in on a little chunk here. So that's a negative 4, negative 6, negative 8. I just zoomed in on a partial graph here. So as you get to negative 8 from the right-hand side, so that means I'm coming at it from this direction. So I'm going to follow which road map? I'm going to be chugging along this roadway, this roadway, this roadway. So what's the height there? Negative 4. Okay, negative 8 from the left-hand side. So I'm going to follow the other road map. So following this road map, coming in from this direction. So follow this road map, and you're getting close to a negative 2. Okay, this one says as you go towards negative 8, now you got to say if I go from both directions. So as you tackle it from both directions, are you going to the same spot? Nope. So there's no limit. And this just says what is the specific y value specifically at x equals negative 6. So you can't do the open hole. You would have to do this value, which is negative 3. Okay, so you'll have one question on your test like that. Okay, so we're going to do the long method. You're going to have to do it 3 times. Okay, so here we go. x1 is x, x2 is x plus h. y1 is 4x squared, and y2 is 4x plus h squared. Okay, so now I'm going to do the slope, and I'm trying to make the distance between my points eventually get to 0, which means if my points are 0 away, they're actually 1 point, which means it's going to eventually be a tangent line. So the slope is y2 minus y1 over x2 minus x1. Okay, here's me squaring that. Foiling, right? I foil it all. So either just do a foil on the side, or you can think about your triangle. Okay, so then I'm going to multiply it by 4. So 4x squared plus 8xh plus 4h squared. The bottom is always just an h. That's how it's always going to be. And that's why we can't plug our h in, because it makes a bottom of 0. Okay, so the 4x squareds will disappear. Now I'm going to work to cancel my problem away. So the top I'm going to GCF and h out. Now I can cancel the problem away. Once my problem is gone, now I can plug the h in. So what is the limit of this equation? So as I plug the 0 in for the h, that would disappear, and my slope equation, which is your derivative, now we know that word, equals 8x. Okay, and then there could be a question where I say, what is the slope at 5, the x value of 5, and then you just say, well, the slope is 40. Okay, shortcut method, let's just check here. What do we get when we take that times that? We would get an 8, and if we went 1 down, we would get a 1, right? So our answer is right. Okay, number 2, x plus h, those are our x coordinates. The y coordinates are 18 root x and 18 root x plus h. Okay, so same setup here. The limit is h approaches 0 of y2 minus y1 over x2 minus x1. Okay, what is the strategy we learned with the radical question? What should we do? How do we get rid of radical stuff? Times by the conjugate. Okay, so when you do the conjugate, don't forget, when you FOIL, you can cheat and just do the FLA. That's going to happen. Okay, so first times first, I don't know, did anybody do 18? Is it 324? Yeah. 324. The same radical will cancel, so that's just x plus h minus last times last. So 324, and then the roots of the x's will cancel. There is one. Oh. There. You just didn't see it till now. Okay, let's put this through. Thank you. Yeah. So if I'm going to distribute that through, which could make my 324x's disappear. I know you're probably going to want to cross those off, but really you should right one more step, so I'm going to do it correctly. Okay, we're ready to get rid of our problem. The h of 0 on the bottom was the problem, and now it will cancel. Okay, so what do we get? If we replace that h with a 0 now, we can replace that h with a 0, we get 324 over an 18 root x plus another 18 root x. Did anybody do this already? Is it 9? Yeah. So 9 over root x is the slope equation or derivative. Okay, so let's do the short method. Let's just double check here that we got that right. Okay, so this is rewritten like that. I'm just rewriting it. So when I derive it, what's 18 times a half? So that's 9. And then a half down 1 is negative a half. Okay, what do you think? Does that look the same as that? Yeah, that's the same idea. So we're correct. See, it's nice you can check your answers, right? Okay, last one. So you're going to have one of each of these types, okay? So x plus h. You don't have to write this. I just do so you can see it. Okay, so there's my coordinates. Okay, same setup. We're going to do the limit. As our h distance gets closer to 0, y2 minus y1 over x2 minus x1 Okay, so here, the big idea on this one is fractions. So we're going to think common denominator stuff, right? That's going to be the strategy. So between an x plus h and an x, I need to put both of those in. Okay, so that means this first fraction, I'll need to times by x. This second fraction, I'll need to times by x plus h. Okay, don't forget, this would be a spot to make a mistake probably, the negative 24 through, right? That always catches people on the second distribution. And then, don't forget, it's all over h, right? Because the x is gone. Okay, so these are going to disappear. So negative 24h over all that. Oops. And then, instead of dividing by h, I'm just going to rewrite it as a times 1 over h. You don't have to, but I just like to do that. Okay, that gets rid of my problem. That's what I like, get rid of that problem. So once my problem is eliminated, now I can plug in. So this is what I'm plugging into. So if this becomes 0, That's what I'm thinking about. If that h is 0, this would just be an x times an x. And that's it. So let's go back and just check our answer here with the shortcut, because we can do that now. Okay, so I'm going to rewrite this. I don't like the divide by x, so I'm going to write it as an x to the negative 1. So when you derive that with the shortcut, times is negative 24. One exponent lower, and that is the same as divide by x squared, right? That's what we had. Okay, then this is the last question on your test. Okay, get the velocity from 2 to 4 seconds. So this is where we're starting. I need coordinates. 2 coordinate 1. Okay, yes, agree. Anybody like those numbers? Not? Okay, so the velocity is the slope. So y2 minus y1, the second point, over x2 minus x1 56. I didn't give you units, so I should probably tell you, let's go with meters. I didn't give you any units, so pretend that I did. Meters. So meters per second. Okay. I'm not going to tell you the method, but on your test, if I'm going to say estimate at 3. So don't use a derivative. This is just going to be an estimate. So I'm going to go with a 2.9 and a 3.1 because I'm trying to get close to it to estimate it. Okay, so don't do a derivative on this question. And I put in like underline bold, estimate. Okay, so that's just plugging it in to your equation. Okay, are we hopefully good with those numbers? And then I'm going to do the same slope formula. y2 minus y1. And I don't know, I got the same number actually. Maybe they'll all be the same number. Okay, so on your test you won't see me saying that. I won't use close points. I'm not going to tell you to do that. I'm just going to say estimate. Okay, the next question says find the actual. So you're not going to see me telling you what to do because this time you're going to use a derivative, actual. Okay, so I'm just going to write this down so I have it here. Yep.
If you're saying estimate, can we get like the decimal units to like round it?
Like these decimals?
No, like the final.
Did you know decimals?
Well, no, because I just used 2.9 2.99.
Oh, yeah, I don't know, it's just an
Doesn't
estimate.
matter.
Just go to whatever, one. So you used 2.99?
Yes.
Did you did you get 56 or something close to it?
No, I got 55.98, but
Oh,
I was
okay.
wondering if you
It's an estimate.
okay.
Okay, so on this I'm going to H prime it. That means I'm deriving it. So we can use our shortcut. So times is negative 8t with a 1 exponent. So really, I guess there's an exponent 1. So this would be plus 8. And now there's no t on it. Yep. Wait. Oh, AD. Right? All right, AD. Okay, so that's my slope equation. So now put in a time of 3. I probably would have realized I wrote that wrong when I got not close to 56. And look at that. 56. Okay, when does this object hit the max height? So I do know that this is a parabola, and this is the max. So here's what I know. If I was to ever draw a tangent line there, I actually know the slope of that tangent line is going to be 0. So when does the tangent line, so this is the tangent line equation, right? The derived equation is the tangent line equation. It's the slope equation. When is the slope 0? Okay, so I'm just going to add AT. So when it's 10 seconds, we're at a max height. Okay, last question. What is the max height? So we're obviously going to plug in 10. But here's my question. Where am I plugging 10 into? The derived equation or the original equation? The original gives me my height, because the derived equation gives me my slope. And I don't want to know slope, I want to know height.